Okay, so
Okay.
there is no
Okay.
problem at all. Yeah.
Okay,ค่ะ
All right. Okay, Karish. So let's go ahead. Last time I gave you some homework in science. Did you research on that homework?
Yes.
So what did you find?
Um, the sunlight take to reach Earth. Sunlight take 8 minutes and 20 seconds to reach Earth, and the sun is 150 million kilometers or 93 million
Okay.
miles away from Earth.
All right. And one more thing was there. You shared some of I guess PPTs. I wish to know about what that was about teaching or what. What do you want me to do with those PPTs?
What I have learned in the school.
Okay, you shared that. All right. Hmm. So that was your learning from school, right?
Mhm.
Do you want to revise that with me?
Okay.
Okay. So do you want me to revise those topics or you are okay with all of those?
Anything is
Charis,
fine. Anything is
anything?
fine.
Okay. So I may put some questions because you've already learned those things from the same PPT, so you may be able to revise all the things in a better way, right?
Mm-hmm.
Or I can also go with my PPTs. Okay, let's check like what we can do. So firstly, I'm just sharing my PPT, then I'll be jumping to your PPTs, what you've learned from those, right? Okay. So are you ready?
Okay.
Um, I was about to talk about five kind of matters, five states of matter. Last time we discussed about three states of matter, right?
Mm-hmm.
So do you know another two more names in the matter?
Um, I don't think so.
Okay. That was not part of your lesson in your school? All right. So be very much active about five states of matter. We'll be talking about it. So three states we already know. We'll be also revising that in this presentation. So you may write this heading five states of matter on your note. The five states of matter. What are the beginning three ones? Can you name them?
Um, solid, liquid, gas.
Yeah. Solid, liquid, gas, and
Solid, liquid, gas.
yeah. And after that, we'll be talking about. Okay, no problem. So we already talked about the definition and all, right?
Yes.
So we can just revise it. Matter can be defined as anything that takes up place and has mass. And one more thing I've added, that is inertia. Do you understand what an inertia is?
No.
Okay. Do you understand what motion is?
Motion.
Yeah, motion. Do you understand what a motion is?
Yes.
What is motion?
Like moving action thing.
Yes, action things. So inertia is a lack of energy or an ability to move or to put a particle into motion. Okay. So the physical force that keeps things where they are, right?
Mm-hmm.
Or keeps them moving in the direction they are traveling. The inertia can be defined in two ways. Firstly, in general term, like what are the things kept around you?
Huh? What do you said again?
Cherish. What are the things kept around you?
Um,
On your desk, perhaps. What are the things kept around you that is placed and not
solid.
moving? Yeah. Solid, like mobile phones, Your tablet that is kept on your desk, right?
Mm-hmm.
Laptop that is kept on your desk, right?
Uh, your
So give
voice
me
is
some
like
examples like water bottle,
uh,
mouse. Am I properly audible now?
your your voice is
Yes,
like
am I clearly audible now?
yes, you're clear now.
I asked what are the categories are not in motion? Mouse, water bottle,
What are not in motion, right?
camera,
Um,
the objects which are around.
phone, pencil, book, notebook, water bottles.
Yes, yes. Book about inertia. So definition of inertia.
Yeah.
Um, the physical force things they are. The physical force that keeps things where they are.
Hmm? Uh,
The physical force keeps things where they are. Written
the physical force.
keeps things where they are.
Okay.
Or right afterwards, or keeps them moving the direction, or keep them moving in the direction they are traveling,
I keep
or
that.
keeps them moving in the direction they are traveling. Keep moving in the direction they are traveling.
Okay.
Yes. So that is the definition for inertia. What you understood about inertia now?
Its ability to move.
It can be in general, it can be in an so in you can say inability to in general, but sometimes like an object is moving in a direction. It is going, and it keeps on going until a physical or external force is not applied on them. Like for example, our Earth is rotating it on its axis. Do you know that?
Yes.
So, is that in the position of inertia or not? Generally, would call no, no, it is not in position of inertia, but in the position of inertia because that is moving on its axis with interruption. So, something, a physical force keeps some of the stuff in the same position or let them travel in the direction they are traveling. Okay, so inertia is a state of the physical force which keeps the things as they are. Either they are moving the same direction or they are so things which are placed around, they are in the position of inertia, right?
Mm-hmm.
Okay, so now there is a question. Just understand that because science is all about observing and understanding. If I say inertia is a state where the state of showing a physical force where it shows like as the things they are, So for example, if bus is running, so running bus can be called state of inertia or not?
Inertia.
Yeah, running bus can be called that is in
Ines.
the state of inertia or not?
Yes.
Yes. But if we stop them having a break, then would it be called inertia?
No.
Yes, because that is the interruption or external force we have kept to stop that bus. So inertia has been interrupted, right?
Mm-hmm.
It means their state has been changed. Okay, let's say now there is a bus which is standing. Is that in the position of inertia, state of inertia? The bus which is simply standing, no driver, nothing.
No.
Why?
Because it's not moving.
No, 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 no. So inertia is not the state which talks about moving or not moving. It is generally is original state. Now, I'm not talking about running bus. I'm talking about a state of bus which is just standing because there is no driver. That is also part of inertia. But when you kick start, then it breaks, then it interrupt inertia. But when bus is running, then running bus can also be counted as in a state of inertia because that is running. But when you stop that, then it is called interruption in inertia. When that is standing, that is in the position, then it is again inertia. So inertia is something as the things originally are, right? If they are moving, let them move. If they are in position, they are placed somewhere, let them be placed. So this is inertia. So inertia is about a physical force that keeps the things as they are, right?
Yes.
Okay, for example, can you see this mouse cursor?
Where? Mouse what? Ah, yes.
Can you see this mouse cursor? I have placed it here. Can you see that?
Yes.
Is this now in the form of inertia or not?
Yeah.
But now I am moving. Is this now? I'm moving here and there, not in a single direction. Is it now inertia?
Yes.
No, because I'm not going in one direction. I'm moving here and there randomly. So this is not inertia. This is the external force I have given to it, right?
Mm-hmm.
So when you change the state of a position, like running things, you stop, and uh, non-animate thing, you just actually give move to those things. Then it's called interruption in inertia. So matter can be defined as anything that takes up space and mass. Last time we discussed. Now a little advanced definition we have created that also has inertia. Why? Because the particles in every matter is always moving or positioned in a state, right?
Yes.
Okay. So chemistry. Now this is basically we are studying in chemistry. Chemistry is the study of matter and its interaction. What is chemistry about?
The study of matter and its
What is chemistry
interaction.
about?
The
Yes, you
study
may
of
write it
matter.
down. Write a question. What, yes, write what is chemistry about? If somebody asks what is chemistry, then you may tell me what is chemistry about and write the answer.
It's the study of matter and its interaction.
Yeah, it's the study of matter and its interaction. Have you noted that?
Yes.
Noted? Okay.
Mm-hmm.
So it's the study of matter and its reaction. Okay, so matter may react with some of the stuff. Do you know what do we call interaction of matters? How can you define it? How can you explain interaction between matter?
Like, um,
Think about it. We have done certain experiments all together in the first class. Do you remember those? You can pick examples
um,
from those. Yeah.
like gas and gas.
Yeah. Yeah.
Um, the gas interaction with each other is different from solid because solid is like they cannot move freely, they can only vibrate, but gas can move freely and move past each other.
All right. Today we are having a little advanced class over it. Let us dive something more into matter. Can you guess how matter is formed actually? What are the things can be found inside the matter? Can you guess that? What are the things
Solid, liquid, gas.
that, okay, that is the category. Okay, let's talk about solid. So a solid matter is having what's inside, what's into it?
Atoms.
Atoms. Very good. Good job. You gave correct answer. 10 credits for this. Okay. So atoms are found inside the matter. So how can atom be defined?
Um, Microscope.
Sorry. Microscope.
Right.
Microscope is atom or a machine kind of things.
Machine.
I'm talking about the definition of atom.
Oh, it's like a little thing that like have like a lot of them to form a thing, another thing.
Yeah. Lot of them to form another thing.
Yeah.
Okay, you are roughly going well in kind of surface level definition. Okay, let us understand it in more scientific way and formal approach. So when you are talking about atom, it is okay. I'll just let you know the definition. You may write, but now for now, I wish to know that how many categories can matter can atom be defined in? Like, what are the nuances under the matter, into the matter? Do you know those
108
108? What? 108 what?
substance.
Substances. Okay, you're just having guesses. What if I ask you, like, the smallest like particles? Okay, we have reached up to atom, but now we are just making it more, you know, we are diving in the depth into the atom. Like you have just gone into matter, you found atom. But if we dive into atom, what else would we find? So there are certain things which we'll be finding. Something we call nucleus. Have you ever heard about this word, central nucleus?
No.
Nucleus. Okay, so every atom is actually having a nucleus, and that also has something like in nucleus, proton and neutrons are there, and this is negatively charged by electrons. Have you heard about proton, neutron, and electron?
I heard, but I'm not sure.
Yeah. So these are the things which are actually found into the atom. Okay, so whatever you see, let's say this is mouse. I see this mouse. So this is solid, liquid, or gas? Let me know.
Solid.
Mouse is solid, liquid, or gas? Yes. And it is made of plastic, um, kind of batteries there, metal. So some of the stuffs are there. But when we are going into the depth, we find it is actually the formation of atom. Because atom, when atoms are formed, a matter is made, right?
Yes.
And when we are going into atom, we find like there is a nucleus. In that protons and neutrons are there. There is electron that is being negatively charged over it. So there are the things in more nuances. These are electron, uh, proton and neutron. Okay, so let us now understand everything more clearly. So you may write question or heading, what is atom?
Okay.
Atom. What is atom? Write it. So
Yes.
you may write, an atom is the basic unit of, an atom is the basic unit of a chemical element. Uh, an atom is the basic unit of a chemical element. An atom is the basic unit of
Mm. Yeah.
a chemical element. Have you noted?
Yes.
Of a chemical element. Okay, comma, the fundamental building block. The
Mhm.
fundamental building block of all matter. The fundamental building block of all matter.
Okay.
Okay, so this is what we understood now, but there is more to write. So we understood atom is what? The basic
The basic of a chemical element that is the
basic unit. Basic unit. You
basic
haven't written unit. Basic unit. Unit is important because that is the, you can say, um the unit, like matter we found, like atom is unit of the matter, basic unit, and that would be also subdivided in some categories. Okay, so an atom is the basic unit
of a chemical
of
element,
yes, of a chemical element, and it can also be classified as the
the fundamental
fundamental
building
building
block
building yeah, the
building
fundamental
block
building block
of
of
all
all
matter.
matter, right? Very good,
Yes.
very good. Well done. So, now what are the things it may contain? Just let me know. I told you three things. In nucleus, two things are found. And what is negatively charged? Do you remember any name I told?
Proton,
Yeah,
mhm,
proton. And what name do you else?
proton, neutron,
Yes, one more, one more.
um,
Uh,
electron
yes, right. So in the nucleus, two of them is found into the nucleus. What is that? What are those two? In the nucleus means in the center of a kind of atom. Charis, are you there? Charis, can you hear me? Yeah. Are you having network issue, Charis?
Okay.
What happened?
I'm not sure.
I can see. Okay, now wait.
Huh?
Are you there? Yes, are you there?
Yes. I think
OMG,
I think like there's like
am I audible to you now?
Yes, but like sometimes your voice like
There is
you're
what?
saying something. Your voice is sometimes like something like that.
Okay. Now is it clear now?
Yes.
Is it clear now?
Yeah. Right. Is it okay? หนูถามในกรุ๊ปไปนะว่า is it okay having มันเรียกว่าไงมันแบบตะกุตะกะ
not continue เขาบอกว่า like หนูก็บอกเอา
Yes,
process
Karish. Is it clear now? Let me know.
Yes.
Okay. All right. So
problem
I was talking about atom. Hmm?
Your voice
So so till where is my
sometimes
voice clear now?
yes, but sometimes your voice is like missing, like it's not continuous.
Dragging in between, right?
Yeah.
Okay, it would be now much clear to you.
Okay.
So in the atom we have written atom is basic fundamental of an element in chemistry. So let's go into it. And we found in nucleus two things are found. In the nucleus, there are two things. Those are what? Those are
Um,
protons and
proton, neutron.
neutrons. Okay. Yes. Write it down. Just after you have written like fundamental building blocks of the matter, and then an atom consists. An atom consists of. An atom consists of a
Consist
nucleus
uh,
of a nucleus
uh,
Nu
in you,
Cleus.
Cleus, nucleus
So an atom consists of a nucleus of
of
protons,
oh,
protons,
how to spell tons?
protons,
PRO
Protons,
T S
Pro
yes, T O
Protons,
N S. Okay.
and
Yes. And
yes, and neutrons, Neu,
an EU
Neu,
and EU
Trons,
Trons. Neutron.
comma, comma, surrounded by,
Surrounded
surrounded by,
by
by, yeah, negatively charged electrons,
negatively charged Newton.
negatively charged electrons, not neutrons, negatively charged electrons, ELE,
Yeah.
CTRO,
CTRO.
NS.
Yes.
So now did you understand what an atom is?
Yes.
Yeah. Tell me. What?
An atom is the basic unit of a chemical element. It's the fundamental building block of all matter and consists of nucleus of proton and neutron surrounded by negatively charged electron.
Correct. Well done. So this is what we understood. So we can say in general, but that is not more specific. If somebody asks like which could be the smallest unit of a matter, you may call it like atom. But more specifically, when you dive into it, you find there are some small things as well that can be in the found in the nucleus. That is proton, hmm, and we found like neutron, and we found electron, which is being negatively charged over it. So that's what we understood. Now let's go into it. So the five states of matter, I wish you to take a snapshot of it.
Okay. Okay. Done.
Okay. So here, the three things you already know: solid, liquid, gases. There are two more things. Can you read that?
Bo- bones
Not
in
ba, not bones. No, no, not bones. Read it properly.
B
Bose.
O
How to pronounce that?
B O S E
That is Bose.
bones
Bose.
boss
Hmm.
boss EINSTEIN in
That is name of a
stand
scientist. Huh? Have you ever heard the name of
Einstein.
Einstein? Einstein. Yeah, Einstein. Have you heard name of him or not?
Yeah.
So Bose, Einstein, then
Born Einstein
Bose. Yes,
condenser
yes. Condensate. Condensate. Bose,
condensed.
Einstein, condensate. Okay.
Born Einstein condensed.
Or we may also read it Bose, Einstein, condensate. Both are correct
Born
pronouns.
Einstein condensed.
Yes. Okay. So you must understand this part, this state of matter that talks about like a kind of little description I've written just under it. Can you read that?
Supercoated atom that bunched together.
Yes, that's what Bose-Einstein condensate is. So Bose-Einstein condensate can be classified as supercooled atoms that bunch together. Hmm?
Condensate. Super coated. That bunched together.
Yeah. So when we are saying it supercooled, it specifically means extremely cooled, right? Extremely low
Yes.
temperature. Or you can say near absolute zero, um, causing the atoms to lose individual identities and act as a single quantum entity, behaving like one giant wave sometimes. So that is enabling a phenomena that may called superfluidity and atoms laser. Okay, so this is a special case. Okay, this is a special case where atoms are extremely cooled. to
Okay.
bunch together. Okay.
Mm-hmm.
Um, Solid, you already know. Atoms are tightly packed, usually in a pattern, and liquid also, atoms are close with no regular arrangement. Gases, you already know, well separated with no regular arrangement. But here we have used um, a specific word, that is atom. Last time I did not go in much detail. I did not talk about atoms, right?
Mm-hmm.
But this time we are using that word atom, and we are more specifically diving in advanced science for states of matter, right?
Yes.
And then comes last one, that is plasma. How much have you written?
I'm writing it all because in case I could look back and then know.
Yeah, yeah, please go ahead. How much have you written? Have you written
Um
up?
um I'm onto gas.
Go ahead. So gases are well separated with no regular arrangement.
Rated with no regular arrangement.
Yes. So these are well separated. And when we are talking about plasma, okay, now I want you to read it loud. Plasma.
Plasma. Superheated with atoms spread very wide apart.
Yeah. So plasma is the fourth, or you can say like state of matter, fourth state of matter, an ionized gas of free electrons, ions. Superheated means that one of them we found extremely cooled, and one of them we found superheated with atoms spread very wide. Hmm?
Apart. Okay.
Done?
Mm-hmm.
Okay. So now we may talk both of the things. So what we understood, these two states, the fourth state is plasma, and the fifth state is Bose-Einstein condensate. So we have to just remember this thing. Plasma is all about matter which is superheated with its atom spread very wide apart, and Bose-Einstein condensate is about extremely cooled or super cooled atoms that bunch together. So what do you understand? What is plasma?
Plasma is superheated atoms that is spread very wide apart.
Yeah. And what do you understand by Bose-Einstein condensate?
It's super cool that it's like stick together.
Hmm. Well, we do have some examples for plasma. Would you like to know that?
Okay.
When it's rainy, have you ever seen lightning? Have you ever felt that lightning in the sky?
Yeah.
So that is actually plasma. Okay, superheated with atoms spread. You may write the example so you may remember that. Okay.
Plasma.
Yeah. L-
Lightning.
Lightning and even stars. Okay.
Stars.
Yeah. All right.
Why though?
Sorry.
Why is it like plasma?
Yes, that is a good question. Why is star plasma? So how do you see star?
By light.
Yes, by light, of course, but star can be found on what?
Um.
Of course, in the first class, I told you everything you see around, whatever is occupying space and having volume, and now we also added on that is inertia, is called matter. So we can call stars as matter, right?
Yes.
So stars are plasma because their immense gravity creates such extreme temperature. Okay, stars are plasma because their immense gravity creates such extreme temperature and pressures in their cores, in their core,
Wait.
right?
Um. Star are plasma because They are what?
Their immense gravity.
There
I IMMENSE.
is e gravity. Gravity.
Because their
Because
immense gravity,
yeah.
yeah, creates such extreme temperatures.
Wait. Such extreme temperature
Temperatures and pressures and pressures
and pressure.
pressures
Yeah.
in their cores. Core, cores.
Yeah. CORE.
Yes,
Core.
yes. That atoms are
That atom are
stripped. STRIPPED.
STRIPPD.
Right. Stripped of their electrons,
Of their electron
of their electrons,
yeah,
forming a superheated,
forming a superheated
ionized,
ionized
IONIZED, IONGED.
I said
Hmm? I
C.
Yeah, sorry, Z. That is Z. Z. Okay. IONIZED. Ionized
Yes.
gas of free electrons,
Gas of free like
electrons,
electrons
and
and
uh, and n- nuclei, spelling NUCLEI,
NuCl
LEI,
EI
nuclei. You can write in bracket for understanding. Write in bracket ions, IONS, ions. Nu-
and
yeah, nuclei can be called ions. Okay,
okay.
so this is what plasma is. So star can be plasma because this is the state where something is extremely heated, and due to the gravity, the temperature is too much in this, right?
Mm-hmm.
And pressure is also too much. So this is the fundamental state of matter in which star allowing nuclear fission to occur, which powers the star to emit light and heat. That is why a star can emit light and heat you were talking about. So in the same way, can I say sun is also a plasma? Can it be said? For the same definition would be allowed on this.
Yeah.
Can we give another example like sun? Because sun is one of the star basically, and
Yeah.
that is nearest our Earth. So that's why it looks like. And stars are like there are the stars which are larger than suns. You know that? Do you know that fact?
I think so, but I'm
You
not
think
sure.
so? You may write a question. Are stars larger than sun?
Or
Star larger than sun, and you may find
or
a kind of research on that. There are many stars actually which are larger than sun. Okay, so you have written that question. Are stars larger than sun?
yes.
You will research on that question. Okay.
Okay. Oh,
There are many stars which are larger than actually sun. Okay, so we found like sun can also be an example of what?
um, plasma.
Plasma. Okay. Um, there is something else. I don't want you to be confused with this. In biology, we also study about plasma. That is called blood plasma. So that is something else. Like we talk it in biology. Okay. This plasma we are talking in general chemistry when we are talking of matter. So when you may dive in biology, when you see the word plasma, that is referring for blood. Okay.
Mm-hmm.
Have you heard plasma in biology ever? Have you gone through these things?
I haven't learned biology yet in my school.
Okay, okay, no problem. So, blood plasma, you may write somewhere like there is also a state of plasma that is called blood plasma in biology. Plasma in biology. So, that is a different thing, okay? Blood plasma in biology.
In biology.
Yeah,
Okay.
okay. Um, so there are more like stars, comets, comets, COMET, comet.
Comet.
Yeah, do you know that comet?
C-O-M-T.
METS, comets.
C-O-M what? T-E-T.
COMETS, comets.
Comet.
Do you know that?
The reindeer.
Okay, this is a question for you. And I would just give you a hint. Comets are found in space. Okay. So just write the question. What are comets? Okay. This is
Okay.
your homework to find the answers of. You know, actually, when I talk of science, I really enjoy talking of the things because everything I see around, everything I find like either in a space or somewhere, it looks like anything which I question science is having answer, right? So either you talk of space, you talk of the general observation on earth, right? We are talking of lightning, we are talking of stars, we are talking of um, even solar wind. Yeah, that can also be an example. Solar wind, solar wind. Solar
Solar.
wind. Yeah, solar wind means what?
Solar is like um
Related to sun. And wind
yeah.
means, wind
Wind
means
in air.
air. So solar wind can also be called plasma because that is extremely heated, right?
Uh-huh.
So solar wind can also be an example. Or we talk about comets in space. So whatever we see around us, that can be in the form of in the form of matter, right? I have an interesting question in my mind. Um, we know uh, that there is gravity on Earth and it attracts everything um, to the ground. So whenever you throw a ball, a part of matter into the sky, it comes down because of.
Gravity.
Have you ever wondered about like how come the satellites when they are launched through the rocket? Do you know about satellite or not first?
Headlight.
Yeah, do you know about satellite?
Satellite.
Yeah.
Not sure.
Oh, okay. No problem. So let us talk about the basic. Um, all right. Have you ever wondered that how we are using internet?
Because of the solar panel.
No, not really. Uh, have you ever wondered that how scientists um, come to know about weather conditions in advance?
Mm, yeah.
How? Explain.
Um, not sure.
Not sure. Like Charis, I can't explain it. Science is such a, lovely subject. You may find answer of every questions. Whatever you are doing, whatever you are having in your life is actually having science. So when we are talking about satellite, let's understand this. So scientists are able to find weather condition in advance because of satellite. We are able to use internet. Even in that, satellite plays vital role. You play some kind of
How,
serials on your cable, on your TV channels or whatever.
how
Even
to
in,
spell it again?
sorry,
How to spell the thing?
satellite.
Yeah, satellite.
Sate
SATE.
L
Um,
L I T E T E
LLITE.
satellite. Okay.
Satellite.
You may research on that. You may write question what is satellite. I'm telling you for now. I'll give some brief introduction to it. Okay. You may discuss it with your friends or mother. What is satellite? It is an interesting topic. Okay. Perhaps your mother may know something about it, but I'm just helping you with this. Okay. So let us understand this. A satellite is any object that orbits a larger body like a planet or a star. Okay.
Oh, I know the meaning in Thai.
Yeah, let me know what is in Thai. That is
ดาวเทียม
Dautium. Can you spell it so I can search perhaps?
um
Doubt. How to spell it in Roman? Roman Dautium.
oh wait, can you copy and paste?
Yeah, I
Send.
can. Yeah, write in comment section. Perhaps that is same or not. Let me check so I can help you with the understanding.
That's in Thai.
Have you
I
commented
I,
that?
I commented in
Okay.
the thing.
Mm, I'm not getting that.
Wait,
Um,
then
did you receive my hi?
okay, yeah.
This is Thai. Okay, let me go on Chrome and just find it with you. Wait a moment. Okay. If that is same, then you will be able to understand it well with me because I will be using that knowledge you're already having.
Okay.
But that is not same, then you have to explain what is that. Okay.
Okay.
All right. So let me copy first. Okay. So here we are in English. In English first because I don't know Thai. Set. Oh, yeah. Right. Very good. So I guess you already know Dao Thiam. So what? How to pronounce it?
Dao is like star and TM is like fake.
All right. So I guess now you have prior knowledge to satellite, but it is in your language, Dao Thiam, right?
Yes.
Okay. Very good. No problem. So perhaps you know it already in your language. Now can you explain because you just got to know in your own language. So what is satellite? Explain in your own words.
Um, it's like an object orbiting in like space.
Yes, right. An object that orbits in larger celestial body or space, right? Which can be natural, um, like moon, and as well artificial. But I was talking about artificial satellite, basically. You know what is
Artificial.
the satellite of Earth? Do you know what is our satellite? Natural satellite.
No.
Okay. So satellite can be natural as well as artificial. So let us talk about Earth's nearest satellite. So Earth has one natural satellite. Write this fact on your notebook. Earth, planet Earth has one natural satellite That is moon. What is that?
Um, uh, natural satellite
Yeah, natural satellite for planet Earth is
moon.
moon. Very good. All right. Okay. Have you ever used GPS on your mobile device?
Yes.
What does it do?
Um, show you where which way to go.
Yes. Even that system is working because of satellite. So that is called GPS satellites are there to help you to track the information. Because how come our mobile can access all the data, all the places? Because that is linked with GPS satellite, right?
Mm-hmm.
What are you writing?
The meaning of satellite. What
What
is
have
it?
what have you written?
It's an object orbiting in space, either natural like the moon or artificial,
Hmm. You can also write space as like
used for
celestial body. In place of space, you can also write, or you can just make a mark of arrow. Celestial body. Celestial, celestial.
no.
Celestial body means a kind of space is thing. You may write a spelling
Okay. Um,
C E C
C
E
E
L E
L E
Stial.
S
Celestial. Yeah.
T I
IAL. Celestial.
just
Celestial. Celestial body.
still body.
Yeah. So that can be like, so a satellite is an object that orbits a larger celestial body, or in a space, you said. That can be natural and artificial as well. Artificial means human made. Natural means like moon we have. So moon orbiting in our earth, right? Moon
Yes.
orbiting where? Moon orbiting in which celestial body? Earth. Moon orbiting in which celestial body?
Earth.
Earth. Very good. That's why moon is our natural,
Celestial
no, natural satellite. Moon is our natural satellite.
satellite.
So you may refine your definition once again. So your definition would be for satellite, any object that orbits a larger celestial body. Any object that orbits a larger celestial body in place of space. So this is the more refined definition. Any object that orbits a larger celestial body.
Uh, a larger
Larger celestial
central
body.
body in space, either natural like the moon or artificial man-made, used
Yes.
for communication, GPS, weather, scientific research, and Earth observation.
Yeah, very good. Good enough. I hope now you understood what a satellite is. Since you already had that word, I forgot. Theo, what is that? What was that? What was?
Doubt
Sorry,
doubt
Dao Theo. Yep. Okay, so Dao Thiam. So that is the thing which we covered today. In this, we also came to know about what satellite is, how it function. So let us now come back to our slide we were talking about. So I told you about comets. I told you about stars. Comets you will particularly research on. mm. I told you about sun. I told you about solar winds. They all can be classified as which state of matter?
um plasma.
Plasma. Very good. So these are the things which we came to know today, and they are possible in which condition, like extreme heat or extreme cold, extreme coolness. What?
Extreme heat.
Very good. All right. So these are the things which we understood. Now let us move ahead. So five state of matter: solid, liquid, gas, and fourth one is plasma, and fifth one is Bose-Einstein condensate. Okay.
Okay.
So basis of classification of four types based on particle arrangement. First is particle. Particles, small particles?
Yes.
So first classification would be based on particle arrangement. Second would be based upon energy of particles, and third would be based upon distance between particles. Okay.
Okay. Can I
So
note this down?
you can take a snapshot.
Okay.
All
Done.
right, but note it down later. Let's discuss because time. You have to note it down. You may share your notes in the group once again. Okay.
Okay.
So solid. First thing, based on particles. So particles. This is what we already discussed in basic class. You remember that first class?
Yes.
Basically, we discussed. Today we are diving more specifically advanced. Huh? Okay. So go through this. I want you to read.
Um, solid particle of solid are tightly packed, vibrating about a fixed position. Solid have a shape,
Definite.
definite
Definite.
shape and a definite volume.
Very good. Now, can you explain this? What does it say?
Um, solid, the particle of solid is tightly packed and only vibrate. Solid have a definite shape and a definite volume.
Hmm. What does it say? We already discussed it. You can directly explain to me. In first class, we already discussed.
Mm.
Cherish, Cherish, I asked you something.
It can only vibrate,
Hmm. And particles
tightly
are,
packed.
and does it have certain shape?
Yes, and
Does it have certain
yes,
volume? Okay. What if I say, does it have inertia?
inertia.
Inertia, yeah, inertia. Every state of matter does have inertia. Either it is um, in a state moving in the same direction or it is actually placed somewhere. So every matter has inertia. Okay.
Okay.
So solid also has inertia because solid is matter, right?
Yes.
Very good. So we came to know based on particular arrangement. First one was based on particles arrangement, right? And
Yes.
based upon energy of particles. Energy of particles we did not talk about, but we talked about based on distance between particles. Yes. So the packed together, it means distance is not that much, right? Vibrating, yeah, vibrating, that can be related with energy too, vibrating about a fixed position. And solids have definite shape, of course. This is based on particles. So particle movement, now let us talk particularly. So do you see this? Like we played the game, you remember that in first class?
Yes.
Do you want to play that game once again?
Okay.
Okay, let's discuss. Then we may, if get time, then we'll play. Otherwise, in next class. So particle movement. So this is something we found there, right? In
Yes.
the experiment, in the game we did. Yes. And examples like this is diamond in the form of solid. This is coke or something. So particles are always moving or vibrating in the case of solid, right?
Yes.
Okay. All right. So now it's about liquid. Focus, Caris. Don't play
Mm.
with your hairs. Just focus here. Okay. Um Now read this.
Liquid particle of liquid are tightly packed, but are far enough apart to slide over one another. Liquid have a indefinite shape and a definite volume.
Yeah. What did you understand out of liquid? How would you define liquid if I hide the definition?
The particle are packed closely together, but it can still move.
Hmm.
And um, it have an definite volume, but not shape.
Yeah. So indefinite shape, but definite volume. Volume, right?
Yes.
Very good. Liquids have indefinite shape but a definite volume. All right. It means shape is not indefinite, but it can have the shape of the container it is kept into. That's what we also have to remember, right?
Yeah.
Okay. Particles. So
Um,
particle movement. Yeah. This would be something like this, looking like. So there is a difference you may see. This is more tight and this is little loosened, but still particles are close together,
yeah.
right? So
Yes.
little nuances you may see, like the difference on the name of difference. There is kind of little change, right?
Yes.
So here we see examples: water, some kind of solution. What about gases?
Gases. Particles of gases are very far apart and move freely. Gases have an indefinite shape and indefinite volume.
Okay, may I ask a question? Does gas have inertia or not?
Yes.
Because it would be moving in kind of a direction, and
Yeah.
until you apply external force, it would not stop moving, right?
Yeah.
All right. So particle movement. What do you see here? There is nothing you see inside it.
Yes. Yeah.
But actually there are some particles which are far in this case. If we I want to draw, I can also even draw it, but generally like it is not seen, so it is in most probably that form, because
Mhm.
what we find, we find gas particles are generally not seen, right?
Yeah.
So they can be like this, so far, right?
Yeah.
Moving here and there so fastly. Got it?
Yes.
Very good. So now let's go with examples. What can be the examples? Chlorine, hydrogen. Any other
Mm.
example can you give? Oxygen
Oxygen, carbon dioxide, um,
and
helium.
very good. This is what we discussed. What is plasma? Go ahead with the reading.
Plasma is an o ionized gas.
No, 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 no. ION, that is
I
ion.
oh
ION is ion. So what it would be?
ion
Ionized.
ionized ionized
Ionized. Yes. Say again. Say
ionized
again.
ionized
Ionized. Ionized.
ionized ionized gas. A plasma is a very good conductor of electricity and is affected by magnet field. Plasma, like gas, have an indefinite shape and indefinite volume.
One more important thing here came in the kind of this line, like a plasma is a very good conductor of electricity. Do you understand what is conductor and what is non-conductor?
Um, maybe like creating.
Mm, Nope. Conductor means something which can have electrical if, effect. For example, um, dry wood. Is dry wood good conductor or non-conductor?
No, no,
So that is conductor or non-conductor?
non-conductor.
Very good. What about metals like silver? Is that
Yes.
silver is conductor or not?
Yeah.
Copper,
Copper. Yes.
gold?
No.
You haven't tried it, but you may research it. You will find it amazing. You know,
Mm,
which is the most, mm, um, most fast, or which is the fastest conductor? You may search this. Which is the fastest conductor? Okay, which is the fastest conductor? That is the thing you may find. You may be amazed to see, like, because golds are expensive, so that's why we use mostly copper. Silver is also most fastest, but gold is also excellent in the speed. But because it is expensive, the people are not using it. Where are you, Karishma?
Hmm?
You disappeared. You've
Oh,
gone to your dreamland. Okay. I said gold is also a conductor. You know why you said directly no? Because I understand the reason. Because generally people do not use gold for having electricity. Is the wire, are the wires in your home made of gold?
no.
Generally it is made of what?
Silver?
Not really,
No,
not
no, no.
silver.
Wait.
Copper,
Right.
copper.
Copper, copper. Okay.
Yes. Generally good conductor is copper, it is considered. Okay. But some others can also be used. But gold and aluminiums also they are excellent conductors, but used for specific properties like kerosene resistance for gold and lightweight power lines aluminium. So these are interesting conductors, and interestingly, all the metals, they can be found as conductor, but non-metals cannot be found as conductor. Now, there I gave you another term, metal and non-metal. Do you understand what is metal and what is non-metal?
Yes.
Yeah, what is metal?
Metal is like something like hard or like shiny. It's like
Okay.
it conduct electricity.
Yes. So something which conduct electricity, the definition is related. As I asked you which is conductor, you told like metal, some examples. And when I talk about non-metal, like something which is not having like conduction, like they cannot conduct electricity, right?
Yes.
So metals are characterized by like electrical thermal conductivity, we can say, and shiny surface that reflects light, as you told. So metal can be classified as electrical or thermal conductivity, and shiny surface reflects light, right?
Yes.
Hmm. And when we talk about non-metal, this can be classified as the elements which form negative ions by accepting or giving electrons, but that does not conduct electricity, right?
Yes.
Okay, there is a lot more to discuss in science. So we talked about plasma is a very good conductor. So plasma is conductor or not? Yes, it is.
Yes.
Can you give me a practical example of being it conductor?
Um, Metal.
Metal cannot be, all the metals are not plasma. I gave you some examples. You
Oh,
remember?
star.
How would you explain that it is conductor of electricity?
Wait. No, wait. Satellite.
Satellite is not plasma, my child. Satellite is something else we explained.
Um,
Okay, let me help you. What if you?
Lightning.
Yes, right, right, right. Okay, now explain how did you just get to know these things?
Um, what again?
Yeah, I just want you to explain it. How do you see lightning coming as a
Bec-
conductor? Yeah,
because if you got shocked by lightning, um, it
you will pro
often, yeah,
you will you will
you'll
probably
die.
die.
Yeah.
Right, great. And do you know the interesting thing? Like your body, if I ask this thing, is your body conductor or non-conductor? Human body.
Yes.
Is it? Yes.
Yes.
Because if you touch electricity, what would happen?
Because
It
you
will,
got shocked and die.
yeah, it will reach in your body. Your body will start reacting with it. All the bloods would be sucked. right?
Yes.
Okay. Um, an interesting fact. This is again an observation. Look, I would be teaching science in this way. Is this okay or not? I don't like
Mm.
just going through theory, but
Yes.
observation. This is practicality. Have you
Yeah.
ever have you ever seen some kind of birds sitting on a naked wire and they are not being electrified? Has it ever happened with you to see them?
Um.
No?
Yeah. Not
You
sure.
did you did not understand my question?
Can you say it again?
I'm just showing it again.
Mm.
I'm just sharing it. I just want to show you a picture. Like a bird sitting on naked wire of electricity. So these are the observation you may put in your
Oh,
life. Yeah.
because like because they are like small and like they
Have you
don't
ever
move
seen
much.
these kind of things in your
Yes.
real life? Have you ever seen?
Yes.
Yeah. So I want to ask that why don't they die actually?
Because they like weight their mass and their weight isn't like much.
Is it really about this? I would like to give you this question.
Oh,
A bird sitting on naked wire of electricity don't die. Why? Birds, birds, let me write birds. Birds sitting on naked electricity, wire of electricity don't die. Why? Interesting question. You may research, you may always research like this, or you may directly go on ChatGPT, Gemini, or whatever. You
yeah.
find the answer. Do
Wait,
you see? Yeah.
a bird sitting on a single power line is safe because its body have the same voltage as the wire, creating no potential difference, so electricity don't flow through it.
Did you understand anything out of it?
Um, because the body has no like
Same
potential
voltage.
difference.
Yeah, no
It
potential
has same,
difference.
yeah.
That is the reason they do not die. Hmm? E- Electricity follows the path of least resistance, and the bird's body offers high resistance compared to the wire, preventing a circuit from completing. The bird becomes electro
Become
electro. Oh, yeah, read this.
become uh what?
This place.
Oh, electrocuted.
Yeah, only if this is important thing.
Only
Yeah,
only if touch it too well at once or touch it a while and ground object something completing the circuit code, the
yes,
electrical circuit.
yeah, that's right. If it touches two wires at once, or if it touches a wire and a ground object, because that gives earth, so then it may be caused harm. Same formula, same concept. Electricians apply. Have you ever seen electricians working with wires?
Yeah.
Do you know they also apply, like an electrician touch naked wire, but they don't die.
Um.
See this. An electrician touching a naked, exposed, energized wire is extremely dangerous and can result in severe injury or death. Even a professional, it is a critical safety violation. But sometimes, when a person touches a live wire, now this is talking about the wait. An attendant touch naked wire of electricity and they don't die. They don't die. How? So these are interesting things which you may observe around you. Like this, you may research always, like Google, AI, and everything is with you, right? So
Yeah.
the question which is coming in your mind, just research, put it on your research, and you may discuss that question with me in the class. You will really enjoy science, trust me. Are you enjoying it now or not?
Yeah.
Okay, so an electrician may survive touching a live wire due to several safety precautions and physical principles that prevent a lethal amount of current from passing through their body on the ground. So, first one is insulation and PPE. Electricians wear specialized personal protective equipment, PPE, designed to insulate them from electrical current. No path to ground. Yeah, this is something I wanted to highlight. What are you writing, Karish?
Nothing. Here.
But you're busy, I guess. Are you doing something else? You were being distracted.
No.
I just want to know what were you doing because your eye contact was not there on the screen. Drawing?
No.
Be honest. Our class is about honesty. Honesty is the best policy.
No, but I just really need the toilet.
Oh, okay. You wish to go now or you have 3 minutes because
It's fine.
okay. So this is something I wanted to discuss. No path to ground, proper grounding for severe. You may read this
For
for a
severe electric shock to occur, there must be a complete circuit for the current to flow through the body to the ground. If an
electrician.
electrician is standing on an insulated mat or wearing a rubber soled boot, the current cannot complete this path to the ground, therefore cannot flow through vital organs. This sometimes referred as working hard but isolated from the ground.
Yes. What do you understand from it? Like, but don't try it. It is a precaution. Um, some electricians actually work in this way. They touch a wire, not both of them. Not both of them, remember. Only a wire. If they touch both of the wires, negative and positive, then they will die.
Mhm.
They touch one of them and they are wearing something like rubber soled boots, or they may stand on kind of um
Math?
mat, or they may stand on kind of wooden framed wooden chair. Okay, so they may not be caused with electricity because what is happening there? Electricity.
Because
Yes, yeah,
it doesn't complete the circuit.
yes, it doesn't complete circuit. So this is sometimes referred to as working hot but isolated from ground. So that happens in that case. Did you understand that?
Yes.
So science is all about interesting things. Just see around and just observe that how you relate with the things. Your homework is, I gave you how many questions? How many questions did you write?
Um, one, two, three, four.
Have you written the question related to metal and non-metal?
Yes, yes.
What was that question?
Um, which is the fastest conductor?
Yes. And also write a question.
Is about
Explain, yeah, explain metal and non-metal in detail. Explain
explain.
metal and non-metal in detail.
Okay.
All right. I hope you enjoyed today's session.